Okay, Matrix, what we're going to be dealing with now is the proportionality theorem. It's really called Theorem 1 in the textbooks. But what it says, very simply, is a line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. Now that's quite wordy. So let's have a look at this. What we mean, if you think about it carefully, if the one side, let's take a DE, runs parallel to one of the sides. Okay, so a line drawn parallel to one side of a triangle, so that's DE. In other words, if we've got DE as parallel to BC in this triangle, then a whole lot of information comes out. We can say that this specific line DE cuts the other two sides, which is AB and AC, in the same proportion. Now what it really means is this: if DE is parallel to BC, then if you look at this, whatever the length of AD is, if you take AD and you divide by DB, okay, so you go AD divided by DB, that is actually the same as AE over EC. AE over EC. An example of, a classical example of this would be, for example, if this was, say, 3 and that's 3 centimeters, and there was 2 centimeters, and this is going to be 6 centimeters, and that's going to be, if you look at that, that's 4 centimeters. You'll notice that AD over DB would be 3 centimeters over 2. AE over EC is 6 over 4. You see that there? Which is really the same as 3 over 2. Can you see that there? What a pleasure. So it says the ratio. Now careful, you'll notice that the length of AD does not equal the length of AE. But we can see that it's the ratio of 3 over 2 is 6 over 4. They're exactly the same. And this is called the proportionality theorem. Now there are many other ways you could do it. You could also say, for example, check this out. If you think about it carefully, if you go the whole length of AB, now watch this, if you went the whole of AB divided by DB, so if you took AB divided by DB, so it's the long side over that little piece there, would equal the long side AC divided by that little piece, EC. And so you can create, as long as any kind of fractions as you like, as you could go BD over DA is CE over EA. It doesn't matter how you go, as long as what you do on the one side is the same as on the other side. So you could also say, for example, the whole length of AB, the whole of AB divided by AD. Now what did you do? If you look at that, how did we go about that one? If you think about it carefully, that would be the whole of AB over AD. Now you do exactly the same on the other side. It's the whole thing. It's AC over AE. And this is what we call the proportionality theorem. Now let's explore this in an example, because I think it's quite useful to take this further. Have a look at this example quickly. It says calculate the value of x. Now notice we've got DE is parallel to AB. So this line DE is parallel to AB, which means that you've got a whole lot of ratios. Now you want to find the size of x there. Given that this is 12, CD is 12, CE is 6, EB is 12. Now notice, the length of DC is not the length of CE, so you can't equate those. But what you do know is something very interesting, is if you got the lines parallel, you could say, well look, I want x, so I could say x divided by 12 centimeters. So how did I actually go? I went AD over the 12, AD over DC is equal to, now look at that, that was your first movement, AD to DC. Now you do exactly the same here. You go 2 to 6. You see that there. Now careful, that is 2 centimeters over 6 centimeters. And when you do this, what you do is, it's because DE is parallel to AB there. You see, it's the proportionality theorem. If DE is parallel to AB, then the ratios will most definitely hold true. Okay, so what can we do if you have a look at this? Well, let's think about it. Okay, x is equal to, well, let's make it x over 12 centimeters still. The centimeters cancel, and 2 over 6 is a third. So all we do is we multiply both sides here. So we go x is equal, if we multiply both sides by 12, that's a third of 12 centimeters, because what are you doing? You're bringing that 12 up here, and a third of 12 is 4 centimeters. Now, if this is 4 centimeters, it makes sense, because have a look at this. What is 6 over 2 is 3. What is 12 over 4 is 3. The ratios are the same. You can clearly see that AD over DC is exactly the same. It equals C, if you look at that, EB over CE. AD to DC is EB or BE to CE there. They are exactly the same. Okay, so this is what we call the proportionality theorem. Have a look at another example quickly. Check this one out here. Okay, now you've got to calculate the value of x here. Okay, well, what do you know? If you think about it carefully, we've got this long side AC, we've got this is 6 and that's 2. So what would the long side here be? Would most definitely be 8 centimeters. So if you want to find x, what you really need to do is, if you go x, that would be this side here. So it's going to be CD, okay, is the x, divided by the whole of CA. Now follow the pattern. CD to CA is CE to CB. Look at that. CD, the x to the 36, is 6 to the 8. The short side CD over the long CA is going to be that side over the long one there. You see, so if we fill in the information that we need, let's see. So we've got x divided by 36 centimeters. Now follow the pattern. It's x, this side CD over CA. Alright, let's color code that a little bit. CD to CA is CE to CB. So that gives us what? That gives us 6 over 8. Do you see that there? Okay, so that's 6 centimeters over 8. 8 centimeters. Remember carefully, look again. It's the x over the 36, which is true. Now follow the same pattern on the other side. The x aligns with the 6 there, so it's 6 over the long, which is 6 over 8. I love this. Now look at this. Now we can say, well, x is equal to 6 centimeters over 8 centimeters multiplied by the 36 centimeters, because you multiplying both sides by 36 and it cancels there. Now let's work out what this is. Well, if you look at that, the centimeters cancel. Let's simplify 6 and 8. Divide both by 2. So that will give you 2 or 3 there for 6 over, divide that by 2 gives you 4. Okay, so 6 divided by 2 is 3. 8 divided by 2 is 4 of 36 centimeters. So what would that come to? Let's have a look at this. X is equal to, well, 4 goes into 36 9 times, and 9 threes are 27 centimeters there. And that would be quite cool. That will give you the value of x there. Okay, there we go, people. So that is a pretty important theorem. It's called the proportionality theorem.